All right, good morning, everybody. Today we're going to talk about simplifying expressions with properties. Okay, we've talked about properties in the past, but we're going to talk about them today and in relation to our expressions and at what step we're using which properties. Okay. So I've already filled it out just to save time, okay, because as you can see there was a lot of writing involved. So I've already went ahead and filled it out, but we're going to go over these, each one of these, okay. So we're going to start up here, and as you can see it has the properties in one column, a definition, and then an example, okay. And out through here you see A, B, C, or A through G, okay, and you'll see why this is labeled out here the way it is right now. So let's just look at the properties right now that we're going to talk about. We're going to talk about the associative property of addition. Okay, we're going to talk about the associative property of multiplication. Okay, we're going to talk about the commutative property of addition, commutative property of multiplication, and the distributive property. Now, last week we talked about the distributive property, so kind of a continuation. And on down through here, it says review the following mathematical phrases, okay? The phrase combine like terms and then equivalent expressions, okay? So this is something else we're going to be seeing as well. So let's start back up here at the top, okay? So the associative property of addition, okay? So the definition, when adding terms, the grouping will not impact the solution, okay? So the way that they're grouped is not going to change the outcome, okay? So let's look at an example. So if we have 3 plus 4 grouped plus 1, okay, is equal to, all right, this is the same because when we're grouping them differently, it's not going to impact it, is equal to 3 plus 4 plus 1, and those are grouped, okay? So we see this as 3 plus 4, well, that's 7. And then we'll bring down plus 1, well, that's equal to 8. All right, let's look at the other side. Okay, so we have 3 plus 4 plus 1. Well, 4 plus 1 is 5. Okay, we bring down that 3. So 3 plus 5 is 8. So just because we added the 3 and 4 first on this side, and then we added the 4 and 1 on this side, that did not change our solution, okay? They're both equal to 8. The associative property of multiplication. Okay, so when multiplying terms, the grouping will not impact the solution. Okay, it's the same way addition and multiplication. Just because we group certain terms together does not mean that it's changing the outcome. It's not. So let's look. So we have 8 times 4. Okay, so we would do those first because that's in our parentheses. That's order of operations, parentheses first. Okay, it gives us 32. We'll bring down the times 2. So 32 times 2 is 64. All right, so let's look at the other side. This time we grouped 4 times 2. So we're going to do that first. 4 times 2 is 8. We'll bring down the 8 and multiply. So we have 8 times 8. Well, that's equal to 64. Just because I did 8 times 4 this time, the first one, and I switched it and grouped 4 times 2 on this side, it did not change my outcome. Okay, it didn't matter. Let's move on down to the commutative property. Okay, so the commutative property of addition. Okay, when adding terms, the order in which they are added can change. Okay, so we can change the order around. Now, we've already talked about the commutative property, so we know this. Okay, so 3x plus 5x plus 6x, well, that's equal to 3x plus 6x plus 5x. Okay, so we switch those last two terms. We flip those around. Now, could we have flipped them all around? Could we have said 6x plus 5x plus 3x? Yeah, we could have. Okay, so we can rearrange the order of those. Okay, the commutative property of multiplication. When multiplying terms, the order in which they are multiplied can change. So the commutative property of addition and multiplication, okay, they follow the same thinking. Okay, we can switch how we multiply these. We can switch how we add these. Okay, so this first set is 3 times 5 times 4. Okay, remember that little dot means multiplication. Okay, and we're using that now because why? We've introduced variables. So 3 times 5 times 4 is equal to 5 times 3 times 4. Okay, both sides equal 60. Just because we rearranged, we moved the order around, does not affect the solution. And we get down here to distributive. Now, we've talked about the distributive property last week. So expanding an expression through distributing. Okay, so we're expanding it, the expression. So when we distribute, we're going to have a number, okay, a term, and then we're going to have parentheses, and then we're going to have term or terms, and operation or operations within the parentheses. So we would distribute that 3 to this term, distribute the 3 to the second term, and distribute the 3 to the third term. Okay, so when we distribute, we're just going to multiply, and we multiply. If it is a variable and coefficient, we're just going to multiply the coefficient. Okay, so 3 times 2x, well, that gives us 6x. 3 times 8 gives us 24, and we just bring the operation with it. Okay, we'll bring the variable too. 3 times 1 gives us 3, so we'll just bring the operation with it. Okay, so we all did pretty well on the distributive property last week. So let's look at our phrases that we've talked about and that we've used. So combine like terms. Now we know that we cannot combine unlike terms. Okay, we can only combine like terms. So simplifying expressions by adding and subtracting like terms. Okay, so let's look here. So we have the expression, and it's a pretty good size expression here. Okay, 4x plus 3y plus 7 minus 2x minus 6y plus 3. Okay, so there are 6 terms. Here's 1, 2, 3, 4, 5, 6. 6 terms in this expression right now. Okay, and we can shrink it down pretty far. Okay, so as you can see in this the first step that we have, okay, which is here to here, okay, we rearranged our expression, okay, because we're adding and subtracting, we're using the associative property of addition. So we're going to rearrange these, okay, to put the like terms together. So now we have 4x minus 2x, okay. And if you remember, I told you to do what when we are simplifying? To put parentheses around each term and the operation in front. Okay, so if we do that, we can move them around. So I'm going to take this minus 2x and I'm going to put it up here with the like term, with its like term. Okay, I'm going to take this 6y, negative 6y, and put it up here with my like term of minus 6y. And I'm going to do the same with my constants, 7 and 3. Okay, once I get it here, now I have, here's a like term, here's like terms, here's like terms. Okay, now I can combine like terms. So 4x minus 2x, well, 4 minus 2 is 2. I'll just bring my variable with it. 3y minus 6y, well, 3 minus 6 is negative 3, so minus 3y. Okay, and then I have 7 plus 3, which is 10. Okay. All right, equivalent expressions. Okay, so we're going to be talking about equivalent expressions. Okay, two expressions that are equal but written differently. Okay, so when we can either factor one. Okay, we can simplify an expression. Okay, so there's several different ways that we can determine whether they are equivalent. Okay, so this one, the first expression we have is 5 and then parentheses 2x plus 3. Well, I could use my distributive property and distribute my 5 to the two terms on the inside. When I do that, I would get 10x plus 15. Okay, so these are equivalent because I distributed this one. Okay, which means that I'm simplifying it, and I simplified it to this. So this is the same, equivalent, equal to this. Now, we'll see how the assignment gets laid out, but you might see something like this on your assignment today. Okay, so it says simplify each expression below. Justify each step by using a mathematical property or phrase listed above. Mark the appropriate letter. Okay, so you're given this top expression. Okay, and it wants you to simplify it. Okay, in these steps. Okay, in these boxes below in this column. In this column, when it says justify, you are going to tell me which phrase or property you used to simplify. So let's look at this first one. Okay, so we first need to when we have an equation or an expression that looks like this, we first need to distribute, okay, this negative 3. Okay, that's the first step that we need to do. So after I distribute my negative 3, this right here is what we get it to. Okay, so we've distributed, and then we're going to bring our 5x, our plus 5x down. So what was the first step that we did? Well, E, right? Because we did the distributive property first. Okay, now once we get here, and we had questions like this in our assignments last week. Okay, once we get here, what do we need to do? Is this simplified as far as it'll go? No, because we have two like terms. We have negative 12x plus 5x, okay? We need to combine those like terms, okay? When we combine those like terms, this is the most simplified form that we can write this expression in. So from this step to this step, we used combining our like terms. Okay? We combined our like terms. So that would be F. Okay? Now, on the assignment, I might give you an expression, okay, and then ask you, so this is step 1, step 2, step 3, okay? I might ask you during step 2, what mathematical property or phrase did you use? And you would come back here and you would just tell me, well, on step 2, I combined like terms. Okay? So that's how you would answer that question. If I ask you about step 1, maybe we, well, in this case, in step 1, we use the distributive property. Okay? All right, let's look at this next box. So again, here's step 1, step 2, step 3. Okay? All right, so you have the expression 3x plus 6y minus 4, and this is plus 2 times x minus 6. Okay? So this is given to you, the expression is given to you. So the first step that we're going to do, we need to do the distributive property. Anytime that we have a number on the outside of the parentheses like that, we need to do the distributive property first. Okay? So this line shows us that we have completed this distributive property. Okay? So there's 2x and then there's minus 12. Okay? So we say E, we use the distributive property. Okay? Now, this next step, okay, we put the like terms together, right? Well, 6y doesn't have a like term, but there's constants, and then here's this, okay? So we're adding or subtracting. So we do what? We use the commutative property of addition, because we're adding here. When adding terms, the order in which they are added can change. So we can flip them around. So that is the property that we used right here. So we'll switch these terms around where our like terms are next to each other. Okay? And then the last step, well, we have our like terms together. Okay? We can just combine the like terms. And that's where we end up with our last step. Okay? Okay, sorry about that. Now, with that next sheet, okay, by substituting a value for each variable, you can check that the expressions are equivalent. So you can check and see if they are equal. Okay, just by assigning a value to that variable. So we are given this expression. Okay, so the first thing that we do, now if we go back and look, this says C, right? Well, what did C? Well, C was the commutative property of addition. So what that means is we are going to, well, I didn't write it right here. Well, first we had to do the distributive property, okay? Because we had to distribute right here. All right, you see that says a negative on the outside? Well, that's a -1, so you would distribute that negative to these, okay? So that should be distributive property should be E, okay? So that's what we have to do first, okay? So distributive property is first, okay? Then after the distributive property, okay, we're going to go in and do the the commutative property, all right, of addition. Look, I got all my numbers mixed up. Okay, so we're doing the commutative property of addition. Okay, so we're going to rearrange. We're going to put our like terms together. Okay. And I keep forgetting what that... C. Okay. And then we combine our like terms and combine our like terms, which was F, I think. Yeah, F. Okay. Sorry, I had my letters all backwards there. Okay, so that's what I did. Now, this expression should be equal to this expression. Okay, and if I pick two values and put them in for my variables, so I picked 2 and 1. Okay, so x is equal to 2, y is equal to 1. Now, if you look, I plugged in 2 wherever my x was, okay, and I plugged in 1 where the y. So then I would go ahead and solve this. So multiply and then add and subtract gives me -8, okay, and then I would do the same thing for this one down here. So this and this are equal, okay, because when I substitute my values, my solution is -8. Okay. All right. So you have a short assignment today, and it's going to be asking about the properties. Okay. So I want you to complete today's assignment and then be ready for tomorrow.